Hi, if you're watching this, evidently you're a little bit confused yet on how to get started with the lab that we're doing today. Either that or you missed the lab and so you need to do a retake on it and need an explanation of how this lab works. In either case, oh, wow, can't talk, sorry. In either case, I'm glad you're watching this. I do want to lead you through real briefly the controls that you're going to need to be successful doing this lab today. So you should have the link from somewhere, either inside of OneNote on the lab page or inside the announcement page for me. Mr. Berger students also are given this lab video. I'm not exactly sure where he put the link, but you should have the link to this lab somewhere. If not, contact Mr. Berger or myself. We'll make sure you actually get the link to the lab. It does use PhET. It's a company that does a very good job of creating some things, along with some of the pivot labs we've done, to give you an opportunity to try to do some labs when we're not in the building. In any case, there's several things we can look at in our class. We use this net force thing just to look at balanced and unbalanced forces. Today, we're going to use the one on the far right that says acceleration. So you need to start by clicking on that. Excuse me. I guess I had to click on it twice, once to select it, once to open it. And what we have is a robot, wooden robot sort of thing that is going to push a box with some forces. The best thing to do to start with is just click on everything so that we can see some values of what we're measuring. You'll see now all of these objects down here have some different amounts of mass. During one part of the lab, we are going to keep the mass constant and just vary the amount of force that this robot thing pushes with. During the other part, we're going to keep the force constant and you can change the mass. So in class, we talked about what things you can vary and what things you can't. Right? To change the mass, we just stack some things on top of each other. There is no limit really to what you can stack on top of, other than, after I say that, it did move that down because there's not enough room. So I wonder if it's going to let us put it aside. Nope, I guess not. So 250 is, actually, nope, it would be 300, right? 300 is the biggest force biggest mass we can make by putting those two things together. The smallest mass altogether, if you just wanted a single mass, would be, excuse me, if this robot person pushed on this individual right there. So a couple of things about making this work. You vary the force by pulling on the slider at the bottom. So let me do that. The issue with that is as soon as you let go, it lets go, right? And you don't want to have to hold that there. So what you need to do first, and this is really not intuitive, but you click the pause button first, you move the force where you want it, and then you can click play. And then that force will be applied. All right. The other thing that I wanted to show here, right, there is the applied force. There's also the friction force. What we're really interested in is the overall net force, or the sum of the forces, or the combined effect of the forces, right? It's probably best if we just turn friction off. That way we don't have to worry about it. There are some issues with that. Technically, if friction is off, this robot can't get any traction and can't even push, but we'll kind of ignore that for the time being. Once again, and sometimes you can't make this maybe even numbers like you want. I had a hard time. I can't do exactly 100. The simulation just won't do that. So just pick a number. Right? We're going to be graphing these things on Desmos. So the graph doesn't really care, since you're not graphing it by hand, what these numbers are. Let's stay in the positive part of the forces that we're applying. So let's just say we do want this about 100. Hey, and as I said, after I couldn't get it, I got it. I tried for like 5 minutes earlier today. I'm going to jump between 99 and 101. So, just pick a number. Don't spend forever trying to get it exact. Just get it close. And then to actually see how this thing is going to move, we click the play button. And there will be two things. There will be a speed number and an acceleration number. And then we can pause. This big orange button resets it. We can choose a different force. Oh, sorry, got to pause it first. And I'll try to put that in the written instructions too, right? Pause first. I'm going to get rid of friction again, and then play. Sorry, I'm going to turn everything back on again. So we have a speed and we have an acceleration. Now, once again, I did not change this force very much. It went from 100 to 104. It's probably good practice to change it by at least 20 or 30 newtons between each one of these. We should still be able to get 8 or 10 readings in between the 0 newtons and the 500 newtons even if we change it 50 newtons at a time. All right, so go ahead and do that. Change it by at least 20, 30, 40, 50 newtons every time so that we get several readings inside of here. And you notice if there is no friction, the overall net force is what the applied force is going to be. There we go. And the other thing is the robot will do the splits and sit down as soon as you reach 40 meters per second. So yeah, so we need to reset. It's unfortunate you have to turn these things on each time, but turn them on, click pause, pick a new force, run the simulation. This time I forgot to shut friction off. So I would not use the 208. It is the 114, right, that we're going to look at graphing, because once again, it is this overall, this net force, the sum of the forces that causes the motion that we're seeing. So in class and in the lab, it actually talks about which of these numbers to record. I just wanted to give you a real brief rundown of how this works. Right, so probably better if friction is off. Each time, make sure that everything is clicked on. Pause the simulation first. Set the force where you want it to be. Then play the simulation and record the numbers that you need to record. Once, by the way, once the robot falls down, you can't take numbers anymore because everything stops. We want to know what is going on while this force is being applied. Once the robot sits down, there is no applied force anymore. So that's just a quick rundown. Once again, just make sure everything's clicked on, click pause, set the force where you want to with the mass that you need, depending upon which part of the lab we're doing. Then this will change to play. Right, click play, record the numbers that you need, reset it, and try again. So if this is not enough help, if you get lost as you're going into the lab, by all means, meet me back in the main Teams chat, and I'll go through this with you individually. But hopefully this should be enough to get you started. Have fun with the lab. Let's see what we can learn about force and acceleration.